That's hot. I should grab a pan and some eggs. When I'm doing tedious work like hours of benchmarking, I like to catch up on my reading list, and I'm able to do that with Audible Plus. Audible Plus offers access to thousands of best selling audiobooks, Audible originals, and even podcasts. As an Audible Premium Plus member, this month I selected Star Wars Thrawn Ascendancy by Timothy Zahn as one of my 2 monthly free bonus titles to keep. For more information about Audible Plus or to get your free trial, click the link in the description below. Hey guys, welcome to Elevated Systems. I'm your host CJ, and today we're going to check out the Noctua NH-P1 passive CPU cooler. Noctua announced this, over 2 years ago now, and I've been waiting to check it out ever since. Well, they finally released it and I bought one. So today we're going to unbox it, install it on my Ryzen test bench, and do some thermal testing. Now, the test CPU is a Ryzen 3700X, which, if I remember correctly, Noctua said this thing could handle a 9900K way back when they announced it, so it should handle this 3700X then. After all, it is fanless cooling for high-end CPUs, and this, I guess, is still a high-end, just not as high-end as it used to be. It's not as straightforward as just matching the TDP rating of the CPU to the TDP rating of the cooler, because Noctua doesn't do the whole TDP thing. Can't really blame them. TDP isn't really a standard and is different depending on the manufacturer. So Noctua uses their own standardized performance rating, or NSPR, which is based on their own standardized testing, and there's math involved. In any case, this cooler gets an NSPR of 42, and just for reference, this little NH-L9A rates a 61. So according to Noctua, this thing cools better than this thing, but I guess for a better comparison, I should probably get it out of the box. Let's do that. All right, on top, looks like we have our box full of all our mounting kits and accessories. And then it should just be the cooler. Okay, all cardboard packaging. And there it is. Okay, we have 6 heat pipes on a nickel-plated heat plate here. And this is a beefy cooler. So let's check out the accessories. All right. All right, we have our instructions, AMD instructions, Intel instructions, more Intel instructions. Okay, we have what is our AMD installation set, which that's the one we're gonna need. And then you got the common parts. So we have fan mounting clips, because you can mount a fan to the fanless cooler if you want. And this comes with the NTH2 thermal paste. This is their 2nd gen upgraded thermal paste. This is actually, I have tubes and boxes of this stuff. This is the thermal paste I use for basically every single application. Good stuff. It'll get you probably an extra degree and a half on a passive cooler. And then it comes with a Torx driver, because the mounting system that they use, their secure mount, is a Torx-based mounting system. So they give you a nice little Torx driver with it. And then these are the Intel mounting components. So you have your backplate for an Intel socket and your mounting equipment, which we won't need for this one today. I guess let's just go ahead and get this installed on our test bench. So in our AMD set, we have our mounting brackets, and then we're gonna have our mounting standoffs and the screws. So the gray ones are for our AM4 socket, White ones will be for AM2 or AM3 socket, and then our 4 screws. The AM4 or the AMD installation uses the stock motherboard backplate, so that's nice. So installation is pretty simple and straightforward. We're gonna use our standoffs on the posts of our backplate. And then our mounting bracket actually has 2 holes, one that's labeled 3 and one that's labeled 4. So because we're on an AM4 socket, we're gonna use the one labeled 4, and we're just gonna screw those down using the included torque driver, or Torx driver. And then same thing on the other side. Guess it might help if I move that out of the way. There you go. Okay, and you'll notice that these brackets actually curve away from the socket or from the CPU. That's just how they mount on there. Now to mount the cooler itself, first I'm going to use the same NTH2 thermal paste that's included. I just have like probably 5-10 grab tubes of this stuff laying around. And the method I use for applying thermal paste is exactly how Noctua recommends in their instructions, and they're Noctua, they know a little something about heat sinks and cooling. One big dab in the middle, 4 smaller dabs on the corners. That'll allow for full spread across the entire IHS. Now to install this, you're gonna install this with the heat pipes themselves facing your memory. And we're just gonna line up the screws with the mounting brackets here. And then again, using our torque driver, we can slide right between the fins. And screw these down a few turns at a time. And that's it. And that's as easy as it is to mount because there's no fan. It's a passive cooler. We're gonna test this out and see how it does. Now, we're in the middle of a heat wave here in the West, especially here in Colorado. It's like 100 degrees in my office right now. My home AC just can't keep up on this floor to keeping it cool. I'm gonna take this down to the main level where I have a nice testing temperature of about 23 degrees Celsius. So I'll be back with those results. I did the testing in my kitchen where the ambient temps were between 22.8 and 23.2 Celsius. The CPU was set at completely stock settings and all motherboard enhancements were disabled. For the testing, I performed each test twice with the test bench in the horizontal position and then tilting it into the more standard vertical position. I removed and remounted the cooler once and repeated the test again for a total of 8 test runs. The results are the average CPU diode temps minus ambient. Additionally, I performed a single test run using the Noctua NH-P1 Redux 120mm fan set to 1700 RPM. Beginning with the 20-minute idle temps, the cooler maintained average idle temps of 14.1 degrees with an average peak temp of 29.8 degrees. Idle temps were the only test I didn't include results from the inclusion of the fan. In our 30-minute heaven runs, we see max temps peak at 61.9 degrees above ambient, and the average temp throughout the test period was 48.1 degrees. In the Handbrake 4K HEVC transcode test, maximum CPU temps reached 62.4 degrees Celsius and averaged 54.3 degrees above ambient. The Blender Classroom render only pushed temps just a few degrees higher. However, the fan was able to reduce temps a degree or more lower in this test. We're in our 10th pass of Cinebench. We have a CPU temp of 77, a CPU diode of 88 degrees. So on a 10-minute Cinebench run, we stayed well below TJ Maxx on this 8-core 16-thread Ryzen 3700X. And this puppy, that's a hot, but it's doing its job. And I can feel the heat radiating off this thing. I can't even pull the camera back that far, but I'm 2 feet above it and I can still feel the heat radiating. We ended that run with our CPU diode peaked at 89 degrees. That's not bad. Our Cinebench R20 temps, while high, that max temp of 65.9 degrees above ambient is an actual CPU diode temp of 88.9 degrees Celsius. However, like I just said in the clip, this is where the NH-P1 started to surprise me, as I fully expected the CPU to begin throttling during this test. The overall average of those 4 tests resulted in max temps of just 63.3 degrees, and the average of the average temps was just 54.6 degrees. And again, while not the focus of the test, adding a fan was able to reduce peak temps by 22.3 degrees on average, or about 35%. We're not done because Blender wasn't the only surprise, as I also ran a 10-minute AIDA64 stress test, not actually expecting it to pass.
We've hit the max, but it's still running. I didn't shut down yet. Any second now, I think. Oh, we're pulling down the core clock a little here. Oh, we made it.
Now, that single test and one without the fan is all I ran, so these results aren't technically scientifically valid, but here are the results from that run.
Okay, it's actually been a few days since that testing. Some things that were supposed to arrive for this video didn't arrive. I had to adjust the plan. Anyway, those results were pretty good, better than I expected. I fully expected the AIDA64 stress test to fail within 10 minutes using this passive cooler, and it came close to failing. I'm not sure if it would have made it to 11 minutes, but first, the AIDA64 stress test is way more punishing on your CPU than any real-world task you're likely to be doing on a PC. Also, this is basically best case scenario for this cooler on an open air test bench. Obviously, if it's in a standard vertical position, closed off in a case with a graphics card below it spitting out heat, it's just not gonna perform as well, which leads to the question, what is the best use case for this cooler? Now, I've shown that it can handle gaming CPU loads, but a silent CPU cooler in a gaming PC that has a not silent graphics card is kinda silly. Now, my plan was to build a completely passive gaming system with this, but the passive cooler I wanted for my RX 580 seems to be discontinued, and I wasn't able to find any others in stock. Plan B was to build a compact, completely passive, high-end desktop PC, but the small form factor fanless power supply just never showed up. But that's okay, because Noctua actually put together a great video where they build a completely passively cooled silent PC. So if you're interested, I'll put a link to that in the description below. As far as where I think this would be a great fit is in a CPU or APU only home office or home theater PC, where you really want a silent running computer that requires pretty much zero maintenance. So any system with one of the Ryzen G-SKU CPUs with built-in Radeon graphics, or pretty much any Intel Core series CPU minus the F-SKU. I've mentioned before, over 85% of people don't require dedicated graphics cards for what they do on a PC, and most of your best-selling home office desktops and laptops from HP, Lenovo, Dell, they don't have dedicated graphics cards. So if you want a silent PC or a maintenance-free PC, no fans sucking in dust, then this is the perfect cooling option. Now, I will be doing just that. I will be revising one of my home office PC builds using this cooler, but not today. That's a future video because now I'm waiting on the ATX fanless PSU. So be sure to get subscribed so you don't miss that. But today, I want to do something a little more fun, maybe a little stupid, but still fun. I want to build a very powerful home theater PC using the NH-P1 to cool the 8-core 16-thread with integrated 8-core GPU Ryzen 4700G in the InWin Chopin. Now, I know the case is like half the height of the cooler. I said it was gonna be fun. Let's get the cooler off the test bench. Okay, I have everything set up. The whole HTPC is assembled. There's the Ryzen 4700G 16 gigabytes of DDR4 3200 megahertz memory. I would actually recommend 32 gigabytes for this build, but the Corsair LPX is the only low profile kit I have on hand. It's on an ASRock Fatality B450 ITX motherboard. There's a 500 gigabyte Samsung Pro M.2 NVMe SSD on the back side of the board, and a 2 terabyte SanDisk SSD mounted in the bottom of the InWin Chopin. Now, the first modification I made to the case was I replaced the 150 watt 80 plus bronze power supply from the Chopin with the 200 watt 80 plus gold flex PSU from my InWin B1 case, because the 200 watt has a quieter fan, and because of the wattage headroom and gold rating, the fan will spin up less frequently and for shorter increments, because my only real complaint about the Chopin is the PSU fan is loud, and that's no good when I'm trying to build a relatively silent PC. Of course, that isn't the only modding I'm gonna need to do to this to fit this in here. I can always just put the CPU cooler on and leave the cover off, but that's kind of ugly. Now, obviously the cooler is gonna stick out of the case, which I think will look pretty cool. Probably better if I had the silver Chopin, but I do want to use the cover, or most of the cover, and fortunately the mod is super simple. This mesh part is just held on by these tabs. So if I just unbend each of these tabs, then the mesh piece comes right off. Okay, I put the cover on first because it won't fit over the cooler, and I'll be mounting the cooler backwards because I want the heat pipes in the back of the case for a bit of a cleaner look from the front, and also because of the asymmetrical or offset design of the cooler, this will help center the cooler more or less. It won't center perfectly because the motherboard isn't centered in the case due to the power supply, but I guess we'll see how it turns out. I mean, it's probably not for everyone, but I think it's cool, and cool is really what it's about, or cooling. The NH-P1 is perfectly situated for maximum cooling, and the PC is protected inside the case. And now that I know exactly where the cooler lines up in the case, I can mod up some small mesh pieces to cover the little open areas or gaps on each side. I'll throw in some B-roll of that because right now, I want to test this thing.
Rather than running benchmarks, I just added the HTPC to my home theater setup and, well, used it for a couple nights. For this testing, I did test the system in the vertical position, and this time I enabled SoC mode to maintain the integrated GPU clock at 2100 MHz, and enabled PBO, which maintained a single-core CPU boost of 4.45 GHz. And then I just did HTPC things. I watched a 4K HEVC 15 megabit per second movie organically using VLC player, and just for the record, I am subscribed to the streaming service that hosts this film. I just acquired the digital copy of the video for testing purposes, which has since been deleted from my system, but as expected, the PC handled it with ease. The only thing that crashed was, well, my wife, while the NH-P1 kept the 4700G in the 30s, which is in the teens for Delta T temps. I also streamed some video content, some 4K YouTube, great video if you haven't seen it by the way, and the entire second episode of Loki, and again the CPU barely broke the 30s, maxing at 42 degrees or about 19 degrees above ambient. Now, I can do all that stuff on a Ryzen 3 3200G, but I went with the 4700G for some added gaming power. So I played a few rounds of Call of Duty Warzone, which I was able to do at 1080p and maintain above 60 FPS. I also played Mass Effect Remastered for over an hour, but apparently I forgot to hit record. I did grab some footage of Overwatch though, with average FPSs in the low 100s and GPU temps staying at about 50 degrees. Ultimately, after about 2-hour gaming session, CPU temps averaged about 48.8 degrees and peaked at only 64 degrees Celsius, or about 41 degrees above ambient.
Okay, so this build was really me just having some fun because it's really not a practical build. I took the power supply out of a second case to put in this case, and I took the CPU out of a $500 pre-built PC, which pushes the actual cost of this thing to like over $1,000. But the point was to test the Noctua NH-P1, and it performed great, keeping yet another 8-core CPU well within acceptable temperatures, and it did it silently in a situation where silence is nice. So again, I will be doing a full, completely passive, zero fan build inside of a case with this cooler as soon as the fanless PSU gets here. So I'll hold my ultimate recommendation until then, but really, if you're looking for a passive cooler for current high-end CPUs, I think this is the only option. There are passive coolers out there for low power, low core count CPUs, or older Intel and AMD sockets, but for the high power AM4 or Intel 1150X or 1200 socket CPUs, while you can find full passive enclosure solutions, I think this is the only passive cooler of this tier. If there is anything else out there, let me know in the comments below, and maybe I can test more passive coolers against this one. But if you're looking for a passive cooler, this is definitely a great choice, or only choice. Anyway guys, that's it for this one. As always, like, comment, subscribe, and I hope to see you in the next one. Until then, stay safe.